Well, hello everybody. My name's Alan and I like talking about electrics. And in this video, I'd like to discuss and expand on a conversation that I had with somebody this week about earthing arrangements, earthing systems, the letters. What does it all mean? So I said, well, that sounds like a good video. So here we go. And so you know what time it is. What's it all related to? It's all related to the National Rule Book. All right. If you go to the National Rule Book on page 10, you'll find the contents of the whole book. English book similar. This is the Irish book, as we know. And you go to page 10, you go to the contents, and you'll find general characteristics, which is what it is, isn't it? At the end of the day, general characteristics in the rule book is how many amps have you got coming in, how many phases, voltages, the generals of the job. So the generals of the job is, what's the earthing arrangement? How are you going to earth the installation? So down below there, then you'll see the section that says earthing arrangements. So you head over there and you'll be confronted with diagrams, complicated diagrams, appalling diagrams, which you can see here now, hard to follow. So what I'm going to do here now is I'm going to change them over and simplify them and put them in colour and explain what all the letters mean. So just let me get set up and I'll be straight back. Right, so welcome back. Here we go. This is a standard three-phase supply that's coming from a transformer substation near your house. We've got three phases, and we've got a neutral, and the centre of the transformer, the output, they call it the star point. Looks like a star, and it's earthed into the ground. So that's your standard three-phase supply from where we're going to get this earthing arrangement sorted out. So to make it easier again, I'm going to get rid of two phases, all right? So I'm going to end up now with this. So there now, I've got one phase now coming down the street to your house. We've got supply transformer, line conductor, neutral, and earth, okay? So now we start working into the letters. So this is the first one. TNS systems were used in the UK up until the late 60s, early 70s. Basically, it was the old paperlead cables that used to come down the street. So you had your line and neutral conductors inside, and the outside sheath was the earth. The armour and the tape on the outside was the earth. So to show you on this diagram, here's my supply. This dot line here now is the supply side in the street and the house. Okay, so there's your line coming through. Got the main ESB fuse and a breaker, say, going to an installation. Got a neutral coming through. Okay, and we've also got an earth coming straight through. Okay, going to earth metalwork in the building. TNS, right, what does it all mean? T is terra. T is terra. And you're saying, what's terra mean? Terra is Latin for earth. You've heard of terracotta plant pots. The Romans thought that the Mediterranean was the middle of the earth. Mediterra. Yeah, they're flat earth. So T is terra, earth. So basically it means earth, neutral, and separate. So we've got an earth neutral, and then we've got separate, neutral, and protective conductors all the way through the system. All the way through. Terra, neutral, separate. Earth, neutral, separate. All right. So in the early 1970s, late 60s, early 70s, there was a big run on this in England, and this is the way it is in Ireland. I mean, I'm only here 12 years, but as far as I know, since more or less forever, in Ireland, they've been on this system. Okay, TNCS. So what they do here is, instead of putting 3 wires going to your house, you have 2. And when it gets to your house, then it splits into 3. So it's earth neutral, and then combined neutral earth in the street and separate in the house. Okay, and if you look in your definitions, then this conductor that comes down the street, this is the one that's called a PEN conductor, protective earth neutral. So it's earth neutral, combined, and then separate. Now, one that used to get used in Ireland a lot and still gets used in England is the TT, This is where you have a pole mounted transformer at your house and the electricity company don't give you an earth at all. They just give you 2 wires. You have to put your own earth in. You put your own earth rod in. So terra means terra, earth, terra, earth. They put their earth in, you put your earth in. And you have to rely on Mother Earth for the connection. There's a dotted line here, and I'm showing a resistor here because obviously the earth is not made out of metal. The earth is made out of earth. It's made out of soil, rock. So this is not a very, very good conductor. And that's the reason on TTs, everything's got to be on an RCD. In the event of a fault, there's never going to be enough current flowing around this fault loop to trip any breaker. So on a TT, every job has to be RCD'd. And that basically covers your 3 standards in England and your 1 in Ireland. Right? Then there's the oddball ones. Right? Let's get an oddball one going here. Right? This is TNC. Well, now you know, you can sort of guess what's happening here. This is where you've got, excuse me while I go and kill this dog. Right, okay, I'm back from drop kicking that dog out the door. So TNC systems, what have we got? Earth neutral, same again. Combined neutral and earth all the way through the system now, all the way through to the socket or the light. So in other words, in the socket or the light, you have to link the neutral and earths. Can't be done on an installation, can't be done on a regular, forbidden. The neutral and earth's got to be separate. It's in our national rule book. So why have it there? The reason they have it there is because if you decide to get your own generator and you go and like become an eco warrior or something, you can wire up your house any way you like, including TNC, but you can't connect it onto a public supply. So the rule book allows for you doing oddball stuff if you like, but not on the public supply. Okay. And the last one then is very similar to the TT we talked about before, where you have their earth and your earth. But what happens now is, instead of it being a good earth at the supply end, they deliberately put in a big impedance to limit the current, to slow the current down even more. What's the reason for that? The reason for that is that it's only used on private transformers. The only place I ever heard of it being used is in foundries. If you had a big induction furnace and you suddenly had a fault on the furnace and the breaker tripped and 15 ton of metal set in the cauldron and it all froze and went solid, you'd have big trouble. Like, you'd have to dynamite it out. So the idea is on stuff like that where the electric can't go off unless it's a dire emergency, the whole idea is that if you get an earth fault on this, it will set an alarm off. It won't trip the breaker, but there's enough current flowing to set an alarm going. That gives the workers then time to investigate it and figure out to keep the power on at all costs. What does the IT mean? It means impedance earth. Impedance earth. Okay, and that's it. And that's all the letter's done. So there it was, another action-packed adventure. I hope you enjoyed the video. If you did, please click like and subscribe. You know the way it works. And just finally, before I go, one thing that I must say is that there was no dogs harmed. There was no dog cruelty involved. I didn't really drop kick him out the door, though I felt like it. Say goodnight, Ned. Right, okay. So that's it, guys. So all the Sparkies out there, till next time, keep it safe, boys.